Good morning, everyone. My name is Greg Aranda with Graybar, and I would like to welcome you to Graybar's G2 Talk presentation on Aged Infrastructure, Ensuring Yesterday's Solutions Meet Today's Needs. This talk is part of a webinar series we offer each month for our data communications customers. We have a great discussion lined up for you today, but before we get started, I'd just like to cover a few housekeeping items. First of all, if you are one of the first 50 people who join the presentation, you'll receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for questions and answers. Feel free to submit questions throughout the presentation. We'll address as many questions as time permits at the end. Lastly, our G2 Talk webinars are all archived on graybar.com. You'll be able to see this presentation again or recommend it to others. We're happy to team up today with APC by Schneider Electric. As a leading data communications distributor, Graybar works alongside APC to provide cooling and critical power solutions to protect your data center against the leading causes of downtime. You can visit graybar.com to learn more about our data communications solutions. I'm also happy to introduce today's speaker, Vance Peterson, Solutions Architect at Schneider Electric. Vance is an industry veteran with more than 20 years of experience with end users as well as OEM and service providers supporting mission-critical facilities and data centers. Vance's strong background in both electrical and mechanical engineering, along with a balance of risk and operational management, make him a key contributor to designs, products, and services supporting data centers. Prior to Schneider Electric, Vance deployed this knowledge and was an operating partner of a life cycle services company specializing in the design, build, and operation of mission-critical facilities and systems throughout North America. Vance is well respected in the industry, and you may find him speaking at an industry event, providing thought leadership with data center blogs, or published articles. So without further delay, I'd like to turn it over to Vance. Take it away, Vance.
Good morning, Greg. Thank you very much for the introduction, and to the audience, thank you very much for taking time out of your busy day today to attend this session. Today, we're really at an unprecedented time in this new digital age, as we say. From smartphones to smart homes and on to the on-demand requirements of nearly everything, data and data center infrastructure are becoming increasingly important to business as well as our lives. We can take a step back and consider perhaps email. Back in the good old days, if email were to fail, it was a nuisance. It might be a bit of an annoyance, but it didn't impact our business. Today, if Schneider Electric loses our corporate email system, business comes to a grinding halt. Another example of this is my favorite little application that I use on a regular basis, the Delta Airlines application. About 2 weeks ago, I was traveling, and God forbid my app quit working. I could not download boarding passes. I couldn't check in for my flights. Really, I didn't know what to do. I've become so trained in using this technology on an on-demand basis that it pretty much caused me to vapor lock. It impacted me. It also impacted my customers. Unfortunately, many data centers from the 90s and 2000s are really struggling to keep up with the new demands of technology and the new demands of customers as well as business. So today, we'll talk a little bit about aged data center infrastructure and how we can help ensure that yesterday's solutions actually meet tomorrow's needs. We'll be discussing what is fueling this fire. We'll talk about some unprecedented challenges that are taking place. We'll discuss some options that you might want to consider to help mitigate and optimize some of these issues. And finally, we'll leave you with some tools and resources at the end of this presentation that you can go forth and use on a regular basis to perhaps help serve as a bit of a guide. Last week, as I was preparing for this presentation, I came across this slide in a corporate slide deck. I've used this slide before, but during this preparation, a light kind of went off in my head. I think I'm a pretty typical person, but yet in the morning when I get out of bed, the first thing I do is grab iPhone number 1, and I use that to check my email. I then usually grab iPhone number 2 and stream a newscast, and sometimes I do this when my wife is streaming music as she gets ready in the bathroom in the morning before she goes to work. I log into my iPad and I log into my laptop and I attach to the corporate servers. I drink my first cup of coffee in the morning and I start my day. Right now, we don't have any kids at home, but we still have 12 devices connected to something through the internet. This is fueling a 23% growth rate across the IP traffic range. By 2018, we're estimating that there'll be 8.6 zettabytes of IP traffic, contrasting that to 2014, where we were measured at roughly 3.8 zettabytes. 23% compounded annual rate of growth. It's a huge number, and it's relatively scary. And this growth rate really blows my mind and causes me to scratch my head. And I asked, what's driving it? And as I was preparing for this presentation, the light bulb went off. We're driving it. This growth rate is really driven by us. It's driven by business infrastructure. It's driven by our customers. And data centers, legacy data centers, have to step up to the plate because it's not going to slow down. And more will be demanded of all of our applications, of all of our data, if you will. In 2015, the population of the Earth was estimated at 7.2 billion people. Contrast that against 2 billion internet users who watched 1.3 million video views per minute across 21 billion network devices. An interesting little fact also is that a commercial airliner typically transmits roughly 40 terabytes of data per flight hour per aircraft. That is a tremendous amount of data that's being pushed back and forth. So growth is really being driven by the number of connected users and the Internet of everything. As third world countries come online, the projections for this growth are very scary. In some cases, in a Gartner report, or a 451 report that I saw, we're estimating that every man, woman, and child on the face of the earth will have roughly 4 connected devices by 2025. That is a huge and staggering number. And this reality really has created challenges that are unprecedented and stress the ability of many of our legacy data centers to perform. Business demands as well as the technology are changing at the speed of light, and data centers are being forced to keep up. All of this combined with business pressure, do more with do less, so to speak, and to meet all of the regulatory requirements along the way, mean that we're in for some pretty interesting times. Again, this trend has created challenges that are really significant and unprecedented in the industry. So how in the heck do we rework a legacy data center built in the late 90s to extract the performance that we need today? And how do we do it to ensure that that same data center can support the business needs of tomorrow? It kind of feels at times like we have a Model T that we need to tune up and make perform like a McLaren P1. And to be perfectly honest, it can't always be done. But sometimes it can, and the majority of the time, some hybrid of the options that we'll discuss today will allow you to reach the performance and the flexibility required for the business needs. So given this, it's time to do some soul searching and ask a few basic questions, realizing that the aging infrastructure might not be up to the task. Some questions that you might want to consider. Does the facility offer enough space to meet the long-term objectives? Most of the time, in our experience, the answer is probably. With virtualization, with consolidation, most of the enterprise data centers that we visit do have space available. They do have white space on the floor that has been reclaimed, if you will, through virtualization and consolidation activities. Next question to ask, does the facility really have enough power to support future growth? Again, through virtualization and consolidation, we've seen some interesting trends. We've seen the trend of increasing rack power density, but yet the overall power requirements within the data center have declined. or typically may have declined? Also, does the infrastructure support today's redundancy level requirements? This is an interesting question. When I first started my career, high tier 2, tier 3 data centers were kind of the norm, and that's what everybody was striving to build. And then we introduced tier 4 data centers, and for a period of time, they were all the rage. Do we need that today? Back in the day, most devices were not dual-corded. Today, most devices are dual-corded. Through the advancements in technology, through virtualization and consolidation, we're seeing a real trend that the high tier 2 and tier 3 level requirements of yesterday might not be the requirements going forward. With the advent of the cloud, if you will, it's now possible to push applications and, to a degree, push data across many sites or multiple sites. So if one of those sites goes away, the impact is not nearly as great as it used to be. So redundancy level, one of the things that we recommend is to understand your true redundancy level requirements. The next question is, does the facility have enough cooling? In our experience, many facilities, the answer is yes. In fact, they're overcooled. Also, with the advances of technology, it's now possible to do things with free air cooling that perhaps we couldn't have done or have done easily 10 years ago. And also take a look at your equipment. Take a good hard look at the equipment within the infrastructure. Is any of that equipment nearing end of life? If it is, that might help you with your decisions and guide along the way. So given this, we suggest that it's now time to stop and evaluate. Evaluate your current business needs. Evaluate your systems, your processes. Evaluate other strategic factors. Review your redundancy requirements again. We need to realize that all loads are critical, but some are much more critical than others, or at least recognize the possibility that that might be the case. Look for opportunities within your infrastructure to consolidate, not just the IT term consolidate, but look for opportunities to consolidate the infrastructure itself with in mind or an eye to increasing capacity and improving overall operational efficiency. Another important evaluation point is the business financial model. Is cash or is cash flow king? Depending upon your company's financial drivers, either cash or cash flow will very likely help you determine whether you want to buy, fix up the old, or move. We'll discuss in a few additional slides later on in this presentation some strategic factors that also come into play. So given this, after I've painted a rather bleak picture, all is not lost. We have some options to explore, and the options that we'll touch on today are tune up your existing facility. Tune it up to maximize performance. Tune it up to create a foundation that can be leveraged going forward, not only today, but also well into the future to support your business requirements. We'll also discuss targeted modernization within the facility. That's kind of a scary term to a lot of folks, but targeted modernization could well keep you ahead of the curve, buying you a little bit of time, delaying perhaps a capital expenditure, or helping optimize your operational expense. We'll also discuss and take a quick look at maybe building a new data center or doing a forklift upgrade on existing infrastructure. Again, kind of scary concepts, but we'll give you some tools that might help, at least in a rough order of magnitude way, help guide that discussion. And finally, we'll take a quick look at the possibility of outsourcing, going to a colocation facility, or moving to the cloud. With regards to buying some time with a tune-up, the first step to consider is to reduce and consolidate the IT. I keep hitting on that, but it's a huge point. Explore virtualization. Does virtualization work in your environment? Can you virtualize? What loads can you virtualize? Virtualization is, as I think we probably all know on this call, is a huge tool that carries along with it some pretty significant benefits. Along with virtualization, take a good hard look at energy management and power capping. Many of the new servers going into data centers today have the ability to be power capped. Specifically what that means is you can tell a 500-watt server that the maximum amount of power that I ever want you to draw is 350 watts. On the surface, this doesn't sound like too big of a deal, but it will help you avoid stranded capacity. It will help bring stability and operational consistency within your environment. The next bullet on this slide, identify zombie servers. I love this because I'm a fan of The Walking Dead. Identify zombie servers. Those are the guys that typically have CPU utilization levels somewhere in the 5 to 10% range. I was involved in a recent project in the Midwest where we had actually, Schneider had been asked to perform a proof of concept on a data center infrastructure management system. As part of that system, we had one of our modules that offered IT Optimize, if you will. And what we did was we deployed our proof of concept, we produced a report, and we presented that report to the end user. That report indicated that 55% of the servers in that particular data center were zombies. The 55% of the servers contributed to an 850 kW connected load. The client took our information, they performed their own audits, and they verified and validated that yes, in fact, 55% of the servers identified were zombies, and they removed those zombies from service over a 3-month period. That produced a net reduction in capacity, or a net reduction in load, of about 300 kilowatts. So they drove their data center requirements from 850 to 550 kW connected load. By doing that, they freed up rack space. They reduced their overall power consumption by 300 kilowatts. They were actually able to defer or push out a planned expansion of their data center. So rather than expanding their data center in 2016, it looks like now they'll be able to push it out to 2018. And all at the same time, they reduced their power consumption and power expense by about $350,000 a year. So given that, consider an IT Optimize module, consider data center infrastructure management to help identify the zombie servers and optimize that operation, or simply perform an audit. Look for the zombies in the environment and get those out. You're paying a huge price for servers that are actually doing nothing. Moving on to cooling, consider tuning up your air distribution and your cooling infrastructure. Huge gains can be made operationally speaking by tuning up your cooling and your distribution. One of the things that we always recommend would be to do a quick and dirty capacity calculation. For every ton of cooling that you have in your data center, you should be able to support approximately 3.5 kW of IT load. So if you have 100 kW IT load, that means roughly you'll require 29 tons of cooling before redundancy. And if you have a 1 megawatt IT load, you'll need about 290 tons of cooling before redundancy. If when you do this capacity calculation, you discover that you're 2 or 3 times over cooling capacity versus load, it's a pretty good signal. It's a good indicator that there's some operational gains to be made. Consider turning off some cooling units, as scary as that might be. Redundancy in cooling is huge. We would never say turn them all off except for the ones you need. But there are some methods to help mitigate that. There are some really simple solutions that can be deployed to help optimize that. Also, as it relates to delta T, the differential between supply temperature and return temperature, ideally we'd like to see that run in the 18 to 20 degree range. If you're seeing numbers during this little quick and dirty capacity calculation that are significantly less than that, that's a very good indicator of the overall efficiency that the system is running at. By doing some things, by helping to improve or raise that delta T, you will not only benefit from increased capacity within the data center, but you will have some efficiency gains as well. Along these lines, make sure that your racks are arranged uniformly in a hot-cold aisle configuration. Seal up the holes, fill the gaps, and use blanking panels. Blanking panels, the addition of blanking panels in a legacy data center are huge. By installing blanking panels alone, I've seen temperature gains on the delta T of as much as 5 degrees. They really help tighten up the operations of the airflow within the data center. Along these lines, consider the deployment of a hot aisle or cold aisle containment, and consider an airflow or a capacity study. With regards to the airflow or the capacity study, many systems now exist that can actually learn your data center operating profile. These are systems that are relatively easy to install, relatively easy to interface with your legacy air handlers or your crack units, and will allow you to operate in a variable mode. So by learning the demands of your data center, the system will actually optimize the operation of the individual air handlers. This doesn't work for every application, but in some applications, it's really a great way to help optimize and help save money. In a colocation recently in Dallas, Texas, that we were involved with, in one data hall that was pushing a 2 megawatt load, we were able to optimize the operation of the cracks, the computer room air cooling units, and these were chilled water units. By controlling fan speed and by adjusting the valve position, we therefore impacted the operation of the chiller in a positive way. We were able to raise the temperatures, the return temperatures to the chiller, gain some efficiencies out of the system, and net a customer a real savings of about $33,000 per month on their electrical bill. That does not include the operational savings that would be generated from the maintenance side of the equation. Lastly, in an aging data center, I cannot focus or stress enough the importance of focusing on operations and focusing on the maintenance programs. As we age, we need more maintenance. Unfortunately, I'm beginning to figure that out. So does our infrastructure. As it ages, it needs more maintenance. When you first deploy a data center, you can get by with perhaps not doing as thorough of a job on your maintenance regimen as you might otherwise. But as that infrastructure ages, maintenance becomes more and more of an issue. We strongly suggest that you create or update methods of procedure and emergency operations procedures for the data center. We also strongly encourage the operations teams to be very well trained. Drill on these procedures. Reduce the chance of maintenance or operations action resulting in a problem and minimize the effect if problems occur. It's a very good idea to also create contingency plans and document what-if scenarios. Run your operations team through those contingency plans. Get their input. Ask their input. These are the smartest folks that you have with respect to the infrastructure. Get their input and get their help. And play what-if scenarios. What if our load is forced to increase by 500 kilowatts in the next 3 months? What if we have another 50 racks because of a business process or business change or business initiative that we need to drop into this environment in the course of 30 days? Is it possible? How would it be possible? What would we do? Maybe the answer is we can't do it. Maybe the answer is we would have to take some portion to the cloud, or we would have to move to a colo for some portion of that deployment. But at least have those thoughts, have those discussions, and have your contingency plans mapped out. And again, bring the operations teams into that discussion, and they will help kind of plot the course for the new path. As far as maintenance goes hand in hand with what we just talked about. Proper maintenance of infrastructure is critical, particularly as it ages. We strongly recommend that you establish a baseline for all mission-critical components and stack rank those according to risk and according to criticality. Identify the infrastructure that's near or at near end of life, and use this information to uncover any potential imminent problems or failures. It's been proven that a comprehensive proactive maintenance program combined with a predictive analysis regimen can help stabilize and extract additional value from an aging infrastructure. Partner with your service provider and OEMs to create and perform a stem-to-stern maintenance program for both power and cooling that's tailored specifically to where your data center is at in its life cycle. It's very likely that the maintenance program that's created for a data center that's 5 years old would be very different than the maintenance program that's created for a data center that's at year 10 or year 12 or year 15 of its life. Use this data and proactively replace bad batteries, old capacitors, valves, belts, heaters, bearings. The old saying, which is very true, an ounce of prevention is worth a pound of cure. On the right-hand side of this slide, I've included a simple table that kind of helps outline, as it relates specifically to the UPS, what some of the typical service life is for the components contained within. And as you can see, batteries would typically need to be replaced in 3 to 5 years. Capacitors, DC caps at 5, fan assemblies 5 to 7. One of the single biggest causes of UPS failure that we see besides human error are fans, these little fans that keep the semiconductors and the electronics inside the UPS cool. Many of them in many systems are not monitored. So if a fan fails, you might not receive an alarm until such time the fan that was blowing the cold air across the control board and across the circuit board causes that circuit board to fail. Then you'll know about it because your UPS will fail and you will drop your loads. So proactive replacement of fan assemblies is huge. Power supply units, same thing. Power supply units are the devices that keep the logic within a UPS powered up and operating. Those typically have a service life of approximately 10 years. So I've included in this presentation a little bit of a case study. I wanted to help quantify the value of some of these discussions, if you will. So this is what I call my low-hanging fruit model. It's a little mini case study, and it originates in White Paper 171. It's available on the Schneider website, and I think Graybar put that up on their site as well. In this case model, or in this case study, this is a Tier 3 1 megawatt data center that was only ever utilized or designed to be utilized at 900 kilowatts. The derating was largely due to air mixing at the rack level in the original design. So we took a look at tightening up the data center, tightening up the airflow requirements with the addition of blanking panels, brush strips, sealing up the floor, making everything nice and tight, straightening out the airflow patterns, adding some cold aisle containment. All of this bought us back, or bought the end user back, about 100 kW of additional capacity. So that was 100 kW that they already had, they already owned, they just couldn't use. But through these changes, and with the addition of a custom aged asset maintenance program, they were able to reclaim that 100 kilowatts, and they were able to deploy an additional, I think they were able to move additional 30 racks into the space nearly immediately. The first cost of this work was about $2.10 a watt. The 10-year total cost of ownership equated to about $17 per watt, and we contrast that against a colocation, what the 10-year total cost of ownership going into a colocation facility be. And this number is a number that a lot of people might take exception with. It might push one way by $10 or another way by $10, but for this case study, we landed on 62. This yields a break even in less than 1 year. But not too bad at all. Probably not very difficult to get authorization to do that type of work. So next, let's move on to a targeted modernization within the facility. Once we've completed our baseline and our stack ranking, we're able to move forward with perhaps a targeted modernization. Modernization does not really mean wholesale replacement of everything old with everything new. Targeted modernization was designed, or is designed, to update systems or components that'll give you the biggest bang for your buck, or offer the best performance gain or risk reduction. With a UPS, again, for example, many times older UPSs can be made nearly new again simply by refreshing the batteries, the capacitors, the fans, the power supplies, the static switches, the SCRs, and the IGBTs. We have a white paper 124 that kind of helps guide through this process. In modernizing an UPS, you have to keep in mind it's not a UPS, but it can be made plus or minus about 90% new again, and they can also be equipped with warranty periods, although the warranty period will be a little bit shorter, maybe by 1 or 2 years. The same holds true for cooling modernization. Several manufacturers, including Schneider, have or are working on thermal upgrade programs that will offer customers an advanced replacement of fans, variable speed drives, and control systems to really tune up, make more energy efficient, and make more reliable and make more predictable cooling systems that are already deployed within your data center, your legacy data center. Similar services are offered for electrical and distribution switchgear. We now have low voltage breaker assemblies that can go into existing switchgear cells, replacing the old style breakers simply by plugging into the cell. This will save 60 to 70% the replacement cost of new switchgear, and it will give you a brand new fresh breaker with all the intelligence that you would need to integrate with your building management system or integrate with a DSIM system, or provide the level of information on capacities, current voltages, and loading that you would need to help operate that data center in a very reliable, predictable manner. If density, capacity, or redundancy is really the issue, consider installation of a pod. And a pod-based architecture, in my mind, is 2 rows of racks that are typically contained. They may include integrated cooling. They may include or may not include integrated power, such as UPS and or distribution. The beautiful thing about pods and a pod architecture is they're environmentally neutral, and they offer targeted availability, targeted redundancy, and targeted capacity. Pods can be deployed into legacy data centers in any way that meets your business requirements. With the adoption of a pod-based architecture, it becomes possible to repurpose a section of a legacy data center, to develop, if you will, a self-contained zone that will allow you to drop in whatever the heck it is you want to drop in. Again, redundancy can be customized, power can be customized, and cooling can be optimized, all to meet your exact requirements, and you can leverage as much or as little of the existing infrastructure as you need. This slide actually depicts a client project that we worked on many years ago. The issue that the client was having is it was a legacy data center, and you can see the green squares around the edge. Those are the air handling units. Airflow in this facility was not very good, and the customer was struggling with density. They needed to deploy some blade servers. They needed to deploy some higher density 1U boxes, and the infrastructure simply was struggling to keep up. So one of the solutions that was discussed was freeing up a portion of the data center and dropping in a total of 4 pods. These pods were self-contained. This facility did have chilled water. So the pods integrated some cooling. The pods integrated 2N UPS across 2 of the pods, internally redundant N+1 UPS across 2 of the pods, and it gave the customer a landing zone that they in turn could deploy their blades and their higher density servers in a controlled environment that did not impact the balance of the legacy data center. What you see on this picture, slowly on the left-hand side, slowly migrated over time into the data center or the pods on the right-hand side, ultimately freeing up everything on the left-hand side of the data center. Ultimately, the customer then collapsed that data center to be contained within just those 4 pods that you currently see. And here's a little case study on modernizing to create a higher density zone. In this case study, we added a 100 kilowatt zone, again, 4 kW per rack. The pod included 2N UPS, and the target PUE for this was 1.35. The first cost to upgrade to this type of a zone or a pod architecture was about $4.80 a watt. The total 10-year total cost of ownership came in at about $22 per watt. And again, contrasting that against the $62 per watt to move into a colocation facility, break-even occurred in less than 2 years. And on the right-hand side of the screen, you can see the dark green line is the line that was plotted for moving into a colo, while the amber line or the gold line represents the cost to upgrade. And you can see where those two lines cross. That's your break-even point. And it's right at 2 years, a little bit less than 2 years, actually. So how about ripping and replacing your existing infrastructure and replacing it with new? Or, for that matter, building a new data center. Many times, replacing old with new is more expensive and it's less risky. At least it's more expensive and more risky short term. This said, longer-term reliability is likely better. Efficiency could improve a little bit, and the useful life of the data center, the useful life of the infrastructure, could double. Also, given this approach, you have the ability to right-size your infrastructure, and you could take advantage of some rebates, grants, or perhaps even gain a tax advantage or two along the way. But in doing this, we have to be very, very cautious. We have to be very, very careful. Planning, preparation, and execution are required to pull off a successful project. If one of those three pillars is not there or executed poorly, the project can go off the rails very, very quickly. This said, many companies, Schneider included, offer services that lend a hand with these specialized kinds of projects. And the decision to replace a legacy piece of equipment with a new piece of equipment or upgrade a cooling unit to a newer cooling unit becomes pretty simple. If the vendor doesn't support the system any longer or the OEM doesn't support the system any longer, if spares are unavailable, perhaps in some states, I'm from Oregon, so in some states there are some utility rates or utility rebates that are allowed and pretty aggressive and pretty attractive for replacement of units with efficiency. And of course, if you have some unserviceable parts that have failed within the system, those are likely to cause you to pull the trigger on a brand new replacement. So given this, another little case study. In this case, we looked at the addition of a 500 kW power and chilled water module pushing against a 450 kW IT load. Target PUE was 1.35. First cost to upgrade, $8.45 a watt. 10-year total cost of ownership came in at about $27 per watt. So against our $62 per watt colocation, total cost of ownership, break-even occurred in about 2 years. So again, not too terribly bad. As far as building a new facility, we also took a look at that. A 1 megawatt facility, we assumed that we could build for about $12 a watt. Some would argue that that number is a little too high. Others would argue that that number is a little bit too low. There are lots of people building 1 megawatt data centers for $9 or $10, and there's a lot of people spending $14 to $16 on those same types of facilities. We targeted 4 kW per rack. We included in these calculations a lease rate of $5 per square foot per month. We included a battery refresh in year 7 with a target PUE of 1.3. 10-year total cost of ownership to build a new facility came in at about $42 per watt. Contrasting that with the 10-year total cost of ownership for the same colocation facility move, break-even would occur in about 3 years, 3.5 years. So again, not too terribly bad. And finally, let's take a look at outsourcing or moving to the cloud. Lots of factors go into a move to the cloud or outsourcing to a colocation. And in my opinion, excuse me, it's really as much of a business decision as it is an emotional one. A lot of factors come into play: cost, cash flow, appetite. and less tangible but not less important strategic factors. Drivers that might include what's your level of facility expertise, what kind of regulatory environments do you live in, and really what's your company culture. The process to evaluate these is not always clear, and it can get a little bit confusing. So we've given you some soft issues that you might want to consider. One, what is your company culture? Do you want a data center? A lot of companies, the answer is absolutely. We want to maintain and control our own data center. In other companies, very large companies, CEOs, CIOs, and CFOs have come out and publicly stated we will never own, build, or operate our own data center. It all depends upon the company culture that you're dealing with. What's your comfort with IT equipment in a shared space? Sometimes some customers, given their processes and procedures, have no problem. Other times, it presents huge issues, huge security issues, huge regulatory issues, presents a lot of challenges. Another question to consider is, what's IT's access to actually the data center going to look like if we co-locate? Can my guys get there when they need to get there? What if something happens at 3 o'clock in the morning? Can we gain access to the facility? And will we be able to gain access to the facility? Meaning, if a storm is causing the problems, will we be able to get our IT staff from point A to the co-location center in a timely fashion? Also, what's the comfort with dependence upon contract terms? In co-location facilities, SLAs play a huge part of the contract negotiations. What happens if an SLA goes south? It becomes an issue and it becomes a challenge to deal with, honestly. Some quantitative issues that you want to consider back to facilities experience. Do you have staff? And is that staff comfortable and skilled at operating a data center for tomorrow's needs? If the answer is yes, great. If the answer is no, then that might make your choice a little simpler. What's your regulatory compliance environment? HIPAA is a good example of this. What's your life expectancy of the data center? If you only need additional capacity or you only need additional compute during the holiday rush, cloud computing might look pretty darn attractive. If your demand is a little bit more flat and consistent, then maybe not. And what about deployment time frame? If I have 50 racks that need to come into my data center in the next 2 weeks and I only have room for 10, the decision's pretty easy. It becomes a pretty simple equation. And of course, with the financial model preferences, the perceived size of the capital investment becomes a question. Is doing that $200,000 upgrade, is it a lot or is it a little? Well, the answer to that's probably it depends upon relative to your size. $200,000 is not so much money for a company like Schneider Electric, but for a startup, it's huge. And also consider your cash flow model preference. A lot of companies might have a lower total cost of ownership, but a higher capital expense model. If you're a little bit more comfortable spending money out of pocket up front and you want to maintain or control your OpEx a little bit better, maybe building is the way to go. In terms of co-location, if you prefer a higher total cost of ownership but you want to smooth out your OpEx, then maybe co-location is the way to go. It just really depends upon your company's financial cash flow preference. So one of the things that we've done is we've generated a evaluation scorecard to help with some of these decisions, and this is contained in White Paper 171. It offers an evaluation chart that scores from 1 to 10, things like facility experience, your regulatory issues, your company culture, and the total score is going to range from 10 to 100 using this scorecard. The lower numbers would suggest that maybe considering doing it yourself, so to speak, would be the route to go. And the higher the score, the more you might want to consider looking at the cloud or perhaps going to a co-location facility. And also, we've created a series of trade-off tools, and I hope people on this call have actually seen some of these tools. If not, they're available online. They're very simple, automated tools that allow you to play what-if games. They allow you to run scenarios, and they give you rough order of magnitude savings, numbers, information, data, if you will. We have a whole toolbox full of these tools, and the tools, quite honestly, range from the data center build versus colo calculator, the traditional versus open compute calculator, prefab versus traditional calculator, data center design planning calculator. I think we have a total of about 15 to 20 of these tools available. And again, these are rough order of magnitude tools. They're agnostic, and they've been designed to help run scenarios and play what-if games. They're very easy to use, and I would encourage everybody to go out and take a look at that toolbox and play with it a little bit, because it really can kind of help guide you in a lot of cases what your options might be in dealing with an aging infrastructure, and what you might be able to do to tune it up or make it meet your needs going forward into the future. And with that, I'd like to thank you very much for your time this morning, and I welcome any questions that you might have.
Yes, thank you, Vance. Great presentation. Like Vance said, we're going to open it up for questions. I got a couple here in the hopper, but if anyone out there does have questions, just click on that Q&A box at the bottom and go ahead and type them in, and we will queue them up for Vance. So, Vance, based on your experience, I'm looking forward, what's the average rack density we should be planning for?
Oh, that's a great question, and I'm one of those engineering types that 5 or 10 years ago, we were touting some really scary numbers. We were saying that average rack density would increase to 25 to 30 kilowatts by 2016. To be perfectly honest and frank, we're not seeing that. That hasn't happened. That hasn't happened for a number of reasons. Advances in the IT kit, advances in technology have really dampened the effect of what we thought would happen. So currently today, as you'll note in this presentation, I kind of picked on 4 kW per rack. That's the high end of the average that we see, unless a customer is doing some high-performance compute or they have some very specialized needs. The target density of 4 kW per rack is pretty average, in my opinion. But I'd love to hear some of the feedback from the folks on this call.
Okay, great. Here's a question. How flexible are the pod-based architectures when it comes to third-party server cabinets?
A pod architecture is really a configuration or how you assemble the racks and what you do with the heat and the power going to and from that rack. So a pod-based architecture in Schneider's world uses our SX rack, which has a guaranteed compliant. We can fit any kind of server you might want in that rack. That said, we're seeing some changes in the industry, and we're seeing, if I were pulling out my crystal ball and looking down the road 10 years to a data center that I'm planning to build or retrofit today, I would probably be taking a really serious look at a rack that's 30 inches wide, maybe 48 inches deep. That kind of goes a little bit against the trend that some of my colleagues are seeing and talking about. But again, if I take out my crystal ball and look forward into the future, I want a rack that's a little bit wider and a little bit deeper so I can kind of future-proof my environment. And those racks, really any racks, will lend themselves quite nicely to introduction or integration into a pod.
So speaking of pods, like how small can a pod be deployed in a data center?
In the last 5 years, I've generated 40 rack pods, and I've also generated what we consider a 1 rack pod. So pods can be big or pods can be small. It really depends upon your use, and it really depends upon your specific needs. But in a single rack pod, if you will, really what a pod is again, it's an environmentally neutral island. So in a single rack pod, we can design systems that offer N plus 1, or 2N power redundancy. Same with integrated cooling, N plus 1 or 2N cooling. And you do that in a single rack footprint with the cooling sidecars We add some containment to the front and some containment to the back, so it becomes this environmentally neutral little island that won't impact your existing legacy operations, but will support and supplement them going into the future.
Okay, cool. Does Schneider have a facility where we can see these type of solutions?
We certainly do. Schneider operates the Schneider Electric Technology Center in O'Fallon, O'Fallon, Missouri. We have everything that we manufacture within that facility in a live environment. In fact, that's where Schneider's corporate data center is. So when I can't get my email in the morning, I blame them. But the Technology Center is a wonderful place to visit, and you can work with your friends at Graybar to arrange a tour.
Okay, great. Got a question about battery life here. You mentioned 3 to 5 years for battery strings, but I've read recently there are expectancies for battery strings up to 15 to 20 years based on proper maintenance. Do you see that being realistic, and how?
Typically, UPSs incorporate VRLAs, valve-regulated lead-acid batteries, and they are very temperature sensitive and use sensitive. I always tell my customers with VRLA batteries, plan for replacement beginning in year 7. If you've put them into a harsh environment, if you've discharged and recharged multiple times, you can expect a little bit less life. But 7 years is what I typically begin looking at for a VRLA, unless there's some underlying conditions or circumstances. Some of the newer battery technologies that we have available, some of the advanced battery technologies, absolutely you can expect 10 to 15 years of life in a traditional format, if you will. Right now we're doing an awful lot of work with lithium-ion batteries, and in my opinion, there's still a lot of work to go yet with the introduction of lithium-ion into mission-critical environments. That said, lithium-ion holds some real promise, and it holds some real operational gains. We're seeing the possibility for battery life to exceed 15 years in footprints that are perhaps 1/3 of what they currently are. Higher power densities, more capacity, in a package that'll last a heck of a long time. That said, Schneider currently does have a few UPS offers with lithium-ion. We will shortly have lithium-ion integrated into our large UPSs. But the jury's still out, in my opinion, on exactly what lithium-ion will mean for us long term. But it sure looks like a good option for us to extend battery life and save some operating expense along the way.
Okay, great. Well, I think that's all the time that we have today. So I'd like to remind everyone that there's plenty of white papers out there, and we'll send those to you. We'll put them on our archive page where you'll find this presentation and a bunch of other G2 Talk webinars for data communicators, for datacom installers and data center operators at graybar.com. So Vance, I want to thank you again today. Really appreciate the presentation, and we'll see everybody out there next time. All right, thanks, Vance. We'll see everybody next time for G2 Talk.